All right, everybody, we've got one more lesson to do here. Let's just put it out of its misery. The nice thing about this lesson is there's nothing new to be learned. It's just an application lesson of what we've already done, and then you are absolutely done for the summer. So what this lesson is you are going to be given diagrams of circuits where you have to solve for something on the circuit, kind of like before. But in order to get the solution, it ties a few things together that we've learned. And that's why up top here I wrote, if I zoom in on this a little bit here, I wrote down that by now you have 4 different tools that you can use to fully solve circuits. First of all, you have what's called Ohm's Law. And Ohm's Law is V equals IR and all the different rearrangements of that. Now, Ohm's Law can be used at any point in a circuit. You can use Ohm's Law to calculate something in a battery. You can use Ohm's Law to calculate something at the resistors. If there's any place in a circuit where you have 2 known values, you can use Ohm's Law to calculate the other value at that place in the circuit. In this circuit here on example number 1, there isn't any one place in the circuit where you have 2 values given, but more on that in a second. So you can use Ohm's Law. You can use what you already did before, the behavior of current. So you had some laws for how current behaves in a series circuit and laws for how current behaves in a parallel circuit. I'm going to switch to pen here and maybe it'll be a little bit darker. This pencil's fairly light. We did a lesson on the behavior of current and the behavior of voltage in series and parallel circuits. So that didn't have any formula associated with it. It was just understanding the laws of how current divides when it goes through different branches and how voltage stays the same, etc. And then yesterday, or the last day's work, you had equivalent resistance. Equivalent resistance, where even without any voltages and without any currents being listed on a circuit, you can always work with just the resistors, and that will give you the equivalent resistance. So what does all this mean? Well, you're going to get questions like this both in tech classes and in electricity classes. If you're going to college, you'll probably be taking electricity classes in a whole variety of disciplines. You'll get very simple circuits like this where they'll ask you to find something. So this question here, example 1, says, in the following circuit, solve for the current that flows through the battery. Here's the battery here. So we want to know what the current is at the battery. Well, there's a problem. There's no current given on the whole diagram. And there is the voltage at the battery given, 120 volts, but we can't even take that value and copy it to different parts around the circuit because it's a series circuit. And if you remember what voltage is, that means that the electrons have 120 volts of electricity when they leave the battery, 120 volts of energy, and they have to deliver it to these drop-off points, these resistors. And there's no way to tell just by glancing at this diagram how much voltage is going to be delivered to each one of these resistors. So you can't use the behavior of current. Current's not even listed on there. You can't just glance at this and use the behavior of voltage because you don't have enough information to do that. Ohm's Law, if there's any point on the circuit where you have 2 values at that one point, you can do an Ohm's Law calculation, but that doesn't help you because at the battery you're only given 1 number, and at each one of these resistors you're only given 1 number. So the only way to start this one kind of only has one way to do it. The only way to start this question is you have to do equivalent resistance. And that's what you have to do. You have to go through your laws one by one, or your different things that you can apply, and you have to say to yourself, what can I do to get an answer here? And it's open-ended. That's what you have to understand too. It's almost like a Sudoku puzzle if you like doing Sudokus. You can approach things from whatever strategy you want in whatever order you want. There is no right or wrong way to do these necessarily. In this first example, though, there's really only one of the strategies that will work, and that's equivalent resistance. You do have all three of these resistances given, and it's a series circuit. So the equivalent resistance of a series circuit, Req, in a series circuit is R1 plus R2 plus R3 plus, you just keep on adding them. So that will definitely work here and work out very easily, because you know that R1 is 10, you know that R2 is 30, and you know that R3 is also 30. So the equivalent resistance in this circuit is definitely 70 ohms. And one thing I didn't mention about equivalent resistance, because I was waiting until today, when you solve equivalent resistance, that's the resistance at the battery. So what we can do now with this value is, right here at the battery, we can confidently say that R equals 70 ohms. Okay? And I noticed in college and university that what they will often do is, as a little subset number, a little subset number at the battery, they always put a little 0. They label things 1, 2, and 3, or 4, 5, 6 for different loads around the circuit, but the battery's always 0, I guess because it's like a starting point. Okay, so where you go from here, because this question's asking about the current at the battery. Well, now that you have voltage and now that you have resistance, you can always do an Ohm's Law calculation if you have two values. So right here at the battery, without even using the rest of the diagram, we definitely know that we can use V equals IR to solve for anything else that you need at the battery. And so let's just rearrange that. I would equal V divided by R, and you have your values. The voltage is 120 volts. The resistance is 70 ohms. Sorry, I'm running out of space here. Divvy that up on a calculator. 120 divided by 70, and you're done. The current at the battery is 1.714 amps, and then you could round that however you want. So, I mean, maybe you think this is tricky just by going through one example. That's why we're going to do some more. But the bottom line to understand here is there is nothing new knowledge-wise that you need to learn. You're just applying what you already know, and it's not always, the path to follow to get the answer is not always just one way of doing it. So this next question, example number 2, I printed the diagram for the question, and then I printed it 2 more times, because we're going to do it 2 different ways on purpose to show you that you can think about things different ways. Alright, this question says, in the following circuit, it's a parallel circuit, solve for the voltage at the third resistor. So that's over here. At the third resistor, the final answer to this question, we want to know what is V3. And that's it. That's the only thing we need to know. But in order to get that answer, you have to solve for other things all around the circuit. And I guess that's important to mention as well. You don't just target exactly what you want to solve for and say, okay, how am I going to get it? If you try and do that, you'll be thinking very narrow-minded. Instead, just look at the entire circuit and solve for anything that you can get on that circuit anywhere using any rule. That's what you want to do. Your ultimate goal is to try and get 2 numbers on one spot anywhere in the circuit. That's what you try and do first. Get 2 numbers on one spot, because you know that as soon as you have 2 numbers on one spot, you're golden. You can use Ohm's Law to get the third number, and then all your rules open up from there. So let's see what we've got here. There's different ways that we can do this question, and I should probably get you to do this on your own. If you want to pause the video, go ahead and try it on your own, and then let's see which of the 2 strategies that I'm going to go through matches how you did it. So if you want to do that, hit pause right now. Okay, so whether you paused or whether you're back again, let's do this, and let's do this 2 different ways to show you that you have multiple options. So again, this is what we're solving for right here. You want to solve for what is the voltage of the third resistor. Okay, so all 3 of these resistors are the same, 10, 10, 10. The current at the battery is given as 12 amps. And understanding my current laws, I understand that 12 amps is going to travel out of this battery, and it's going to split down 3 different paths, and then it's going to come back together again. And because these resistors are the same value, you can confidently say the current is going to split evenly between those 3. So the easiest way to start this question, if you know your rules and you know how to do things, is to say to yourself, the current is going to evenly split 3 different ways. So right away, you know that the current that goes down path number 1 is going to be 1/3 of this 12 amps. So it's going to be 4 amps. The current that goes down path number 2 is also going to be 4 amps. And the current that goes down path number 3 is also going to be 4 amps. And then right away, from that rule, I now have this right here. I now have 2 numbers in one spot, and I'm looking for the other one. So to finish off this question very easily, I'm going to use Ohm's Law right here in this little circle here. The voltage at that battery is the multiplication of the current, which is 4 amps, by the resistance, which is 10 ohms. It's going to be 40 volts. Oh, sorry guys, I didn't realize I was off the screen until I just looked at the camera. I wrote this calculation off the screen, my apologies. So one more time, in this circle there are 2 pieces of information. So I'm going to do Ohm's Law, V equals IR. The current is 4 amps, the resistance is 10 ohms, multiply those together, you get 40. And that would be the end of that question. How else could you do this? Because like I said, you have multiple options. So let's look at a different method. This method isn't more right or more wrong. It's just to stress to you the idea that there is no starting point, there is no proper direction that you have to follow here to get the answers. You're free to do whatever you want. So what else could you do? You want to solve for the voltage right here, voltage number 3. Well, you've got 3 resistors in parallel, and if you remember from last day, you can calculate the equivalent resistance of resistors in parallel by adding up the inverses. 1 over R1 plus 1 over R2 plus 1 over R3. I guess this is maybe a little bit longer, this method, but so what? I mean, you're going to find that you have more and more time available. Whoops, that's a plus sign. You're going to find you have more and more time available to do things as post-secondary draws nearer. So, yeah. Sorry, truck going by there. You don't necessarily look for the shortest ways to do things all the time. Alright, so we could add up the inverses of these resistors and get the overall resistance, the equivalent resistance. 1 divided by 10 is 0.1. Remember, I was telling you, convert these fractions right away into decimals. Okay, so the equivalent resistance of this entire circuit is going to be the inverse of 0.3, or 1 divided by 0.3, if you isolate this for equivalent. 1 divided by 0.3, and I'll do that on a calculator because I would just want to make sure that I get this absolutely right. It's an unending decimal, 3.33 ohms, and it just keeps on going. That's a little bit of a pain in the butt, but so what? I mean, you can't be afraid of decimals. Okay, so what does that give you? Well, that gives you the overall resistance of the circuit. And if I go back to the diagram then and show you what you can do with this, that means that you have now solved for this right here. The overall resistance at the battery is 3.33 ohms, and it just keeps on repeating. Well, right here there are 2 numbers. And as soon as you have 2 numbers in one spot on a circuit, like I said, you're golden, because then you can use Ohm's Law. Ohm's Law is always the easiest thing to do. So you want to try and get 2 numbers in one spot on a circuit. So I can now calculate what the voltage is at the battery, because I have I and I have R. Voltage equals IR. So if I do this, I've got 12 amps, and the resistance is 3.333, and it just keeps on repeating. Multiply those together, and you're going to get the voltage at the battery. It comes out to exactly 40 volts, no decimal places. Well, that's not the answer to what we're looking for this question. That's the voltage at the battery. V equals 40 volts. However, now I'm going to switch to one of my other strategies, understanding the laws of how current and voltage work. This is a parallel circuit. That means that every electron that leaves the battery is going to travel down one of these three paths. It can't possibly go down more than one path. And then they're all going to go back to the battery. So that means that in this circuit, all voltage will be dumped off at battery number, or resistor number 1, for things that go through that. So that voltage is going to be 40. Resistor number 2, the voltage at resistor number 2 is going to be 40 as well. And finally, the voltage at resistor 3 will also be 40. So a little bit longer of a method, but that's what you have to do. Sometimes you'll stumble upon short methods, sometimes they'll get a little bit longer. You just have to know that you've got multiple options to continue. I put 3 practice questions on the homework sheets. That's why it looked like there were more sheets today. Some of you probably, as you were printing it, thought, holy man, this is the last day of the class and I'm printing 5 pages. It's only because of all the empty space. And you want to show as much work as you can for these so that you have that work to show yourself in the future. But you'll be able to do a lot of this in your head. And you should go through these 3 questions. It's probably only going to take you 10 minutes to go through all 3 of them. I am going to post solutions to these 3 questions today. I'm not going to wait until tomorrow. I'll post them much later though, because I want you to go through this. If you've only watched this video and it's already much later on Thursday, and the solutions to these are already posted as a second post for today, try not to use them. Try and do these questions on your own first, because what's important here in this work is the thought process. You have to have the thought process. There is no formula calculation that's going to give you the right answers. You have to understand how to think about the different strategies all at once. So definitely don't skip doing them on your own, because if you do, you will not be fostering that thought process. I'll post these answers a little bit later today. You can check your own work. And this is it. This is the very, very last lesson. We're going to have one more quiz tomorrow, and that'll be the final mark, wrapping everything up.